Before we move on to our discovery for rational functions, what homework questions do we have from last night? Which number? Number 4? Number 1? Ah, number 1. So number 1 says f of x equals negative 3/4 x. What kind of function is this, Jalen?
I mean, I don't know. But I know.
Yeah.
Huh?
One person said. Yeah. Fantastic. Linear function. Check it out. M x plus b. So linear functions, what's the domain?
Oh, real world.
All real numbers. All real numbers. Any others we'd like to talk about from the homework? Number 8? What does number 8 say? That? Do we see any square root here? Is this not also mx plus b? Still linear. What's the y-intercept on this? 0. All real numbers. What else would we like to talk about? Number 2. What kind of function is number 2? Starts with a Q. Quadratic. All real numbers. Number 4. So 2 and 4 are both quadratic, all real numbers. How did number 5 go? You want to talk about 5? 5 says f of x equals square root of 9 minus x. What part of this should I be paying attention to? Just what's underneath. Good. So I'm going to highlight 9 minus x. What do I do? What can we not take the square root of? Negative numbers. So how do I say that this can't be negative? What do I set this to? Greater than or equal to 0. Great. And then how do you solve this? You're going to subtract 9 from both sides. Is this done? No. Divide by negative 1. Divide by negative 1. We do need to flip the inequality sign. Great job. But this is not a complete answer. What's my final answer? Less than or equal to 9. Good. Would anyone like to see 7, or we're all set with that? Number 7. And then we're going to start our new discovery. F of x equals negative 1/2 x. Ooh, that's not right. Negative 1/2 times negative 1/2 root 3x plus 15 plus 2. What part of this do I pay attention to? Good job. Just what's underneath the root. Is this an even root or an odd root? Even. What invisible number is right there? 2. That's why we call that a square root. We talked about that yesterday. And so now I'm going to take 3x plus 15 and do what? Greater than or equal to 0. What did you guys get as an answer? Remember, negative 5 is part of the answer, but it's not the answer. Good. I am agreeing with you here. I got x greater than or equal to negative 5. And then for our answer, all real numbers, x greater than or equal to negative 5. What did you guys get for number 6? Why is number 6? Oh, yeah, there we go. Odd root. So number 6 said P of x equals the third root of 2x plus 5 minus 7. As soon as I see this odd root, all real numbers. So that's a really nice summary of everything we learned yesterday. Today, we're going to do our second discovery, and these are the coolest looking functions ever. Ever. Yes, these are cool. I know, right? These are cool. Here you go. If you did not grab a highlighter from the bucket, we do need highlighters today. I know that's a half day, so we'll see how far we get, but I think we can get pretty far. What are these functions called? Look at the title. What is it called? Rational functions. Rational functions. All rational means x in the denominator. This is important.
So there's gonna be an X in the bottom there?
X will be in the bottom, and it's going to mean something. So rational functions, rational means x is in the denominator. It's going to be part of our stamp for tomorrow, so remember this. Rational, x in the denominator. So just like yesterday where we were looking to make connections between the function and the graph, we're going to do the same thing today. So this is the graph of f of x equals 1 divided by x. Does this graph seem to be avoiding something? Is it? Yeah. We're just going to pay attention to this one. So go ahead and highlight. Yeah, and once we highlight that, it literally looks like it was about to cross and it's not. Here, it's about to cross and it's not. See how this invisible line is literally pushing the graph like that? Any connection yet to the denominator here? No? Okay. Maybe let's try B. What vertical line is this avoiding?
Y.
For vertical lines, do we remember what the equations of those look like? Is it x equals a number or y equals a number? Try again. X. So here we're avoiding the line x equals, what vertical line? X equals 2. Over here we were avoiding x equals 1 would be right here. 0. Okay. Let's get this vertical line highlighted again. Do we see any connection between x equals 2 and this denominator yet?
No.
Yes. Okay, so this horizontal line, don't worry about that. Just looking for a connection between here, the fact that this is the line that it's avoiding, x equals 2, and the denominator. Well, what would happen if we let x be 2? Really think about that. What's going to happen? What would happen in the denominator if x was this number? Let's try. Let's see. Let's do f of 2. What would I have in the numerator? Careful, numerator. 2 minus 1, and then the denominator, what would I have? What is this equal? What's in the, let's start with the numerator. 1 divided by 0. Oh no. Can I do that? We're just testing out this value. We're saying we notice that the graph is avoiding this x value. And then what happens if we plug this in for x? And when we do, what giant red alert do we get? And can 1 be divided by 0? Can we divide by 0? Cannot divide by 0. Oh, no. So if 2 is what makes the denominator 0, how would I write the domain for this function? How do we say I could have any x value except 2? Let's start with all the numbers just like we did yesterday. X doesn't have to be greater than, it could be less than, right? I could pull negative numbers, that's okay. Like if I pulled negative 2 in the denominator, what's negative 2 minus 2? Negative 2 minus 2? Negative 4. Can I divide by negative 4? Yeah, so unlike yesterday, negatives are okay. It's just this one number that we can't have. Let me give you a hint. It's a version of the equal sign. But instead of saying x can equal 2, how could I say x can't be 2? Yeah, cross off that equal sign. What does this mean? X not equal to 2. This is going to be our domain. We're saying you can choose any value for x that you want. It just can't be 2. And why can it not be 2? Well, remember, discovery, we're getting there. If x is 2, what happens in the denominator? 0. And is that okay? No. We're only on our second discovery question. Let's try our third one. I'm not going to lose you again, I promise. What 2 vertical lines do we seem to be avoiding here? Where are they located? 3. So x equals 3 is 1. Where's another one? Interesting. Now we have 2. We have 2 x values that we're avoiding, not just 1. So here we're avoiding negative 3, and here we're avoiding 3. Question is the same. Do we see connections between these 2 numbers and this denominator? Connection between these 2 numbers as x values and this denominator. So here's another, I could factor x squared minus 9 as the difference of squares. Down here, it's another representation. What happens if x is either of these values? 0. Yeah, what's negative 3 squared? 9. 9 minus 9? 0, no good. What if x is 3? 3 squared? 9. 9 minus 9? Oh no. Can't have that happen. So if I were to write the domain for this function, tell me what to write. All real numbers, x not equal to negative 3 or 3. So now let's have a strategy. What if I didn't have the graph? What are we all agreeing the denominator cannot be? 0. So how about we set it equal to 0 and find out what makes it 0, right? Let's do that. So what I just did is I made a choice. I'm choosing to say, let the denominator equal 0, and let's find our answers. How would you solve this for x? Let's add 9. Add 9. What does that leave me with? Good job. X squared equals 9. And how would you finish solving that? What is the square root of 9? What would I get? One answer or 2 answers? Take a look at what you just solved for algebraically and what we said can't be in the denominator. Do you see a connection? It's the same, right? So now we're starting to build a strategy if we don't have a graph. For the purpose of time, I'm going to come back to D tomorrow. Let's answer this question at the bottom. Why did these x values have to be avoided? Because, good job, we cannot divide. This is the big idea today. We cannot divide by 0. Have to figure out what x values, value or values, so I'll put S in parentheses, maybe it's 1, maybe it's more, make we have to find out what x values make the denominator equal 0 and exclude. What does exclude mean? If you're excluded from a group, what does that mean? You're not part of it, right? So that's what we mean. Exclude them, take them out, right? Like here, what two values are we excluding? Yeah, they can't be part of the group. You can choose any other x value you want, just not those two. So here's our strategy. It's a two-step strategy. 1, set denominator. Is it okay if I just write denominator? Yes? Set denominator equal to 0 and solve. Your answer will always be all real numbers, x not equal to whatever you got. Because you're choosing, you're making a choice. You're saying, I'm going to find out what values make it 0. That's what has to be excluded. So we'll say you can choose anything you want, any x value, just not whatever you got over here. As soon as you're ready, we're going to practice. So go ahead and turn the page. In this practice, what do we no longer have? No graph. But we have a strategy that doesn't require a graph. What are we going to highlight in number 1? What's the only piece of this rational function we're going to pay attention to? X plus 9. So take your highlighter and let's highlight x plus 9. What are we going to choose to do? What choice are we going to say? I heard it. We're going to take the denominator, x plus 9, and we're going to set it equal to 0. Very good. X plus 9 equals 0. And to solve this, now we're just going to solve. What do I do? One step. Subtract 9, subtract 9. X equals -9. You just found what would make the denominator be what? 0. And go look over here. If x is -9, what's -9 plus 9? 0, no good. So how do I translate this into an answer? All real numbers, x not equal to, careful, -9. So once again, to stress the strategy, we make a choice. We set the denominator equal to 0 to figure out what x can't be. How about for number 2? What are we going to highlight? Highlight the denominator, x. What are we going to set up? Any work involved? No. So my answer, all real numbers, follow the same sentence here. All real numbers, x not equal to 0. And if we actually look at this, look at number 2 and then look at the graph on the front. This first graph was the graph of 1 divided by x. what was the only x value that we could not have here? 0. And again, if we think logically, anything other than 0 would be okay here, right? Any negative number, any positive number, just not 0. How about number 3? Is there a denominator here?
No.
Well, 3 technically is a denominator, but do you have any x there?
No.
No? What kind of function is this? Quadratic. From yesterday, what do you know about a quadratic function?
You can't.
All real numbers. This is a u. So we've got to bring that back. How about number 4? Is this a rational function? Yes? So strategy, what do we highlight? The denominator, go for it. Yep. So we're going to take x squared minus 16 and make what choice? What are we going to do? Equal to 0 and solve. Yes. Add 16 to both sides. Plus 16, plus 16. I agree with that. I agree that that's half of my answer. Hold on one second. Let me catch up to you guys. Good job. Take the square root. When I take the square root, how many answers do I get? 2 answers. Plus and minus 4. It's just like this one that we did, where it avoided negative 3 and 3. So this graph would be avoiding negative 4 and 4. So all real numbers, x, very good, x not equal to both of those numbers. This graph would be avoiding 2 numbers, not just 1. So let's get a big picture here. Big picture, wrapping up yesterday and today. What are the 3 functions that do not have a restriction? Quadratic, linear, there's one more from yesterday. Who said odd root? What's an example of a linear function? F of x equals, yep, anything where the highest power is 1. So don't get thrown off, like 2/3 x minus 1, that's linear. mx plus b. What's the domain of linear functions? Negative infinity to positive infinity, all real numbers. How about a quadratic? G of x equals? Good, that's our general formula. So here, anything that has the highest power of what? Let me highlight this. The highest power here is x to the first. Anything with the highest power of 2 is a quadratic. What's the domain? All real numbers again. And then an odd root, a 3, a 5, anything with an odd number here. 3, 5, oops, didn't mean to erase it, wanted to highlight it. 3, 5, 7, give me another odd number. 9, the 9th root, 15th root, any odd number there, I know my domain is going to be all real numbers. So in these 2 next questions, we're going to summarize what we learned yesterday and what we just learned. For even root functions, let's highlight that. Even root. Even root. What do we do from yesterday? We take what's underneath. We're going to draw ourselves a little picture. Take underneath the radical and do what? Write me a sentence. You write it. Just one quick sentence. Mr. 142? Hi. Yes, he is. Yes. What do I do with what's underneath the radical? Take what's underneath. We're going to write this in formula, just like we think about it, okay? Take what's underneath. And what do we set it to? What do we choose to do? Greater than or equal to 0 and solve. Our answer will be that. All real numbers, x greater than or equal to whatever we find. So our big choice, our important choice is right here. Taking what's underneath the root, greater than or equal to 0, and solving. When would this inequality sign change direction? Good job. Now, if I have a rational function, and I'll just do an example like this. Remember, any kind of x value, what do we pay attention to? The denominator. Whatever the denominator is, what do we do with that denominator? Set denominator. Good job. We're working right till the bell. We're taking some important notes right now. Equal to 0. This is the choice we make. Equal to 0. And do what? Hold on. And solve. My answer will be all real numbers, x not equal to whatever you find. So here we're going to have an inequality in our answer. Here, a not equal to sign. Your job is the mixed practice. I scratched that. Homework on the back. The practice we'll do tomorrow. Your homework is on the back page. Homework number 2 on the back. Skip the practice. We'll save the practice for tomorrow. Homework is on the back. Drop off your calculators, please, or send someone back with them. Have a great day today.